Good day to everyone. Let's do the galvanic cell today. Please subscribe and share, like the video, comment on the comment section. Please share to your classmates, to your learners, to your friends. Thank you. Let's do this question. This is galvanic cell. The diagram below shows the cell that can be used to measure the standard electrode potential for the following half reaction. So we're given this half reaction, then this and also the diagram. Let's look at the diagram. This is the galvanic cell. This diagram is for the galvanic cell. So we have a cell with a hydrogen ion and Fe ion. So this side is positive. This is positive electrode, meaning that this one is a cathode. This is the cathode. So you must think of red cat, which means the reduction takes place at the cathode. This one is an anode, meaning that you must think of NOx, meaning that oxidation takes place at the cathode. On this side there is a loss of electrons, which means the electrons are moving from the hydrogen to Fe3 plus. Okay, now we're going to use the table to write the half reaction at the anode and the half reaction at the cathode. Let's go to the table. We are going to use 4b, table 4b. As you can see, this is 4b. Then what we are going to do, we are going to write clockwise using anti-clockwise direction. As you can see, we have this arrow, which means we're going to draw an arrow like this. Then if you can look here, we have this arrow, we're going to draw the arrow like that one. Okay, all right, let's continue, which means, okay, let's go. Let's highlight. As you can see here, we have Fe3 plus. Let's highlight hydrogen. This is hydrogen gas. So if you can look here, the hydrogen is above the Fe3 plus, which means let's just copy this to the question. So let's go back to the question. Here we have, let me write here, we have hydrogen, that is 2H plus 2 electrons. Then we get hydrogen there. Then we have Fe3 plus 3 or plus an electron to form Fe2 plus. Then there is that arrow moving up, reducing agent. It is written there, reducing agent. Then there is that one, which is oxidizing agent. Meaning that if we are to choose the reducing agent, we're going to choose the reducing agent. On these twos, the arrow says that hydrogen is a stronger reducing agent. Then oxidizing agent, we're going to choose between these twos, which means this one, the arrow is the strongest is the stronger oxidizing agent. That is, this one is a stronger oxidizing agent, this one is a stronger reducing agent. Okay, then what we are going to do, we are going to use that anti-clockwise direction arrows, meaning that if you can look here, hydrogen, we'll start hydrogen here to obey that anti-clockwise, then this one will copy it as it is. So the hydrogen is in this side, so we have hydrogen to 2 hydrogen plus 2 electrons. Then we have Fe3 plus as already there in the question to form Fe2 plus. Okay, so the reactions is this one, this is the half reaction, this is the half reaction. This is oxidation. This is oxidation, that is an oxidation reaction, which means the first substance is an anode. This is our anode. This one is the red cat, which means the last substance is the what? Is the cathode. This is our cathode. Okay, let's go to the questions. The first question says define reducing agent. 8.1.1 reducing agent. Reducing agent in terms of electron transfer, which means we are going to define based on the electron transfer. Reducing agent is a substance. Is the substance that loses electrons. Then you get your 2 marks. That is the reducing agent. Okay. Now the following question says write down the name or formula of the strongest reducing agent. 8.1.2 the strongest reducing agent. Let's go up. This side is a written reducing agent, which means the one on top is strongest. Therefore, hydrogen is the strongest reducing agent. If you can go to the table says the arrow is pointed up, meaning that now that we have one substance 1 and 2, the one on top above is the strongest reducing agent. This one below is there. This one is this one. This one is the what? Strongest oxidizing agent. This one is the reducing agent. This one is the strongest what? Reducing agent. Okay. So in this case, the reducing agent, the strongest reducing agent is H2 or hydrogen. You can just say hydrogen. Okay. Then 8.1.3 the question says component X complete the second. State one other function of X. Let's go back to the diagram and see X is a salt bridge. So the function for salt bridge is to complete the second. Salt bridge complete the second, that's the first one, but they said beside that one. So it complete the second. Number 2, it allows ions to move. So it's the path for the ions. So it allows ions. The ions can be the cation ion, that is cation, or can be anion. So it allows ions to move. So the ions will move here, right? Other ions will move here. Okay, so it allows ions to move. Another function for the salt bridge is to maintain the cell neutrality. So it maintains the cell neutrality. That is the salt bridge. Then we're done with this question. Let's go to question number 1.4. State one condition for this cell to operate under standard conditions. The first one that you must write is the temperature. So number 1 is the temperature. Which is 25 degrees Celsius. We are going to mark only the 25 degrees Celsius, not the temperature. So number 2, okay, let's write here, it's 8.1.4. So the first one can be a temperature, and the temperature to be standard, it should be 25 degrees Celsius. Then number 2, you can say concentration, 1 mole per dm cube. Then number 3, since there is a gas here, hydrogen gas, so number 3 will be the pressure. The pressure, which is 1 atm. 1 atm. Okay, so let's go to another question, which is question number 8.1.5. Give a reason why platinum is suitable for function as electrode in this cell. Number 1, the platinum is a solid. It is a solid. That is the first thing that comes to my mind. Platinum is a solid. Okay, solid. Then number 2, platinum is a good conductor of electricity. Good conductor of electricity. That is why it is suitable to act as an electrode of this cell. Number 3, what I know about platinum is inert. Platinum is inert. So anyone there is correct in this question. Write down the cell notation. So when you write the cell notation, that is number 8.1.6. First thing that you need to do is to draw the salt bridge, and you must know that on your left will be your anode. This is the salt bridge. Then on your right, there will be a cathode. Now let's go to the cell with the anode and see what is happening there. In this cell, NOx, the anode is hydrogen. Okay, the anode is hydrogen, which means in this side, on the left hand side, we are going to write the hydrogen. Okay, then there is a solution there, that is ions for hydrogen. They must be next to the salt bridge. Then let's go back to the cell. There is also the platinum, which hold the hydrogen, which means we have the platinum here. That is the platinum. The platinum is a solid. This is the phase separator. Then hydrogen is a gas. This is a phase separator. Then hydrogen ion is aqueous solution. This one is is a gas. Then this one is a solid. Once we have different phases, we must have a phase boundary, that vertical line. Okay, on the cathode side, what do we have there? On the cathode, red cat, cathode is Fe2 plus. That is the cathode. Then the ion is Fe3 plus. So on the cathode we have the cathode, which is Fe2 plus. Then we have Fe3 plus. So this one is a solution, aqueous solution. This one is also the aqueous solution, which means there will be no phase boundary because this is the same phase. So there is a comma. Let's go back to the cell. We also have here the platinum. The platinum is a solid. So the platinum is a solid. PT is a what? A solid, which means we must have a phase separator here. Then you get the cell note. This is the cell notation. Now let's go to this question. Calculate the initial voltmeter reading on this cell. That is 8.1.7. E naught cell is equal to E naught cathode minus E naught anode. So we know that hydrogen is the anode. Hydrogen is anode. Then Fe 2 plus is the what? Is the cathode. Then let's go to the table, standard reduction potential table. The E naught of the hydrogen is 0,00. Then let's look at Fe3 plus. It's 0,77, which means we have the cathode, which is 0,77 minus the anode 0,00. Let's confirm. So this one is 0,07, then that one is 0,00. Press calculator, you get 0,77 volts. Now they say the reading on voltmeter becomes 0 after this cell operates for several hours. Give a reason for this reading by referring to the rate of oxidation and reduction. So this question is very simple. Once the EMF becomes 0, once the V of the cell, the reading on voltmeter is equal to 0, then the reactions there reaches what? The equilibrium, meaning that the rate of oxidation is equal to the rate of reduction. Then that question is answered. Then we're done for this question. Thank you. I'll see you on the next video. We are going to do another question on galvanic cell, or we'll just continue to electrolytic cell. We'll decide. Let me see the comments on the comment section. Please don't forget to subscribe. Thank you very much.